In vector, what happens? You have a magnitude. You have a magnitude with a direction. So you have two terms here, scalar and vector. If you remember, there was one concept, distance and displacement. Distance is just like 5 kilometers you have traveled. But when I say I have traveled 5 kilometers north, then you say, okay, this is my displacement, right? When you have a sense of direction with a magnitude. So if I say, all right, if I say something is 5 meters, okay, so 5 meters, this is just a scalar quantity. If I say 5 meters up, or 5 meters up or 5 meters down, something like that, then it becomes vector. So vector is something which can be represented or dotted down on the coordinate system. So you can say this point here, or anywhere you can say this point or this point. This is like 1 1 1. So what you will say, this one unit you go in this direction, then again this one unit, next one unit go in this direction here, right? And then in this direction, and you reach to this point. So it has that direction, sense of direction, right? So this is what vector is, right? So this is what vector is. Any point which you can represent on a coordinate system. Just if you give a point like, okay, this thing is 5 meters long, so that is a scalar quantity you are giving it. But you can, if you have that sense of direction to it, then it becomes a vector. Okay, right? So going to the next thing is how it is represented. So it is like a column form. It is like the conventional thing to write a vector is in this column form. So column form is, it's like just write as this x1 x2, sorry, x1 x2 to xn. So if you transpose it, it becomes x transpose, and then it becomes like this. So transpose is nothing but you reverse the dimension. All right. So if you think of what is the dimension of it, if you think of it, it has n elements, right? And it has one column. If you think, so it will be n cross 1. Just think about that. It's not a matrix. Just think about, like, it will have that dimension, n cross 1, like n elements, n rows, and one column. Okay. If you transpose it, it will become a 1 cross n. So it's pretty simple. You write anything to this superscript xt, and it will get transposed. So if you write this, if you do the transpose of this part, then again it will become your initial x. Okay, so this is the thing. Yeah, and then vector elements. Vector elements are referenced by subscript. All right. So here, if I say x3, so it means in x vector, third element, right? This is the standard notation. So in a vector, whatever subscript that is, it will represent what is the like that is a third or nth element. Okay. And then next, we talk about the addition of vectors. So in addition vectors, in scalars, it's like pretty simple, right? You do 2 plus 3 and it becomes 5. But here we have one more thing that will be accounted, and that is the direction part. So let's say this is A and this is B. So this will become A plus B, right? This will become A plus B. So it will have a additive thing, and it will have a different direction than both of these things, right? The magnitude will be added, as well as the direction that will also be the resultant of it. Okay. Similarly, we have scalar multiplication. This is what this, if you say this is like addition of two vectors. Okay, this you can say this is addition of two vectors. And if you are doing addition of a scalar and a vector, then what will happen here? Here what is happening, your direction is changing, right? Here you, in this case, direction is changing when you are adding two vectors. Okay, but here when you are multiplying by scalar, so let's say this is my vector A. Okay, and I multiplied it by scalar. So what can happen here? your direction might change or might not change, but your magnitude will definitely change. Let's say I am doing this minus 2, I'm multiplying with this a. So what will happen? This magnitude had been doubled, right? This is double now, and your direction has changed. So scalar might change the direction based on the what is the value of it. If it is negative, then direction will change. If it is not negative, if it's positive, then only magnitude will increase, right? If I would have just multiplied by 2a, then this direction, this will be the same direction, and it will go like this. Like if I write like this, right, this will be the vector. All right, this is the vector arithmetic. Similar thing will happen when you do the negative. Right here addition I have talked about. Similar concept is like the subtraction also. Like here a positive, if you do the negative, then you can write like this, right? You can write like this. This is basically a minus b. All right. So minus b is nothing but the reversed b. So in this case, if you think of this is v, if you think of the minus b, so it will be somewhere in this direction. Okay, this is minus b, and this was your a. Just I'm showing this example, and everything, then it will be same, and your resultant will be in this direction somewhere. Okay, so basically addition and subtraction, just the minute change it is like you have just one vector reversed, right? You have one vector that has been rotated 180 degree. All right. Next comes the dot product. So in dot product, what happens here when you do the dot product, then you multiply the corresponding elements, what it is written here, of the two vectors, and then add their products. So let's say I have this 2i plus 3j. So what this 2i and 3j means, right? So this is standard notation. In that, it means x is in coordinate system. If I want to represent it, so it will go, I is basically the x-axis, j is the y-axis. So here 2 unit here in I and 3 unit in j. So this point will be somewhere here. All right, this point is somewhere here, and this is the vector. Okay, and similarly, if I write y is equal to I plus j, so just I plus j. So what it is mean? What it means like here it will go 1 unit, and it will go here also 1 unit, and this vector it will lie somewhere in this direction maybe, right? So it's pretty common notation. I represents x-axis, j represent y-axis, and this whole, if you write it, it means like this point is in 2 dimension, and you can represent it as a vector. So now if you do the dot product, how it will happen? I and I, these two you have to do the sum, right? So that is written here, the summation of the elements, corresponding elements. So what it will happen? 2 into 1. All right, the summation is there. So again, sum 3 into 1, and the resultant will be 5. All right, so then the resultant is scalar, and it can also be thought as the projection of a vector onto the other. So if you think of this is x, all right, and this is y, just think about it here. So if you just projection, you can think of this is what? X cos theta. All right, this is x cos theta. Now what will happen? You are just multiplying this whole y, this is whole y, with this value, scalar value kind of x cos theta. This is x cos theta multiplied by y. So that is what it is like, a projection of vector onto the other, and then doing the multiplication. And that is what A is you are getting. All right. Next, in facing object linear algebra, this is the last concept we are talking about. That is L1 norm, L2 norm. What this is basically, L2 norm, L1 norm. It is like, it is a sum of magnitudes of each component. So Here, A1, A2, A3, what you can think of is like I was talking about 2i, 2i plus 3j or plus 4k. So this is what it is. L1 norm of a vector, if you say, so it will be like modulus of 2 plus modulus of 3 plus modulus of 4. All right. So modulus, what it means, like it is like if it is negative, then it will become positive. So how much it will come out? 3 to 5 plus 4, 9, right? If the example is 2i minus 3j plus, or you can take minus 4k, let's say. So what will happen? Instead of 2, 3, 4, here how you will write it? 2 plus minus 3, all right, and then plus minus 4, right? So minus 3, it will be converted to plus, 2 will be here as it is, and minus 4 will come as 4, and it will also result as 432. Next is L2 norm. L2 norm, what it is happening here, you are doing just, instead of this modulus, you are doing the square and taking the under root of it. So in the first case, just I'll take the one example here, 2. If you square it, it will become 4. And then 3, if you square it, 9. And then 4, if you square it, it will become 16. And you have to do the square root, right? And it will become 29. So where this vector norms are used, this view again you will see these things in regularization. All right. In regularization, what happens? Just I'll give you the basic introduction about that. Regularization. What happens when you are training your machine learning algorithm? All right. So what you expect is to, you have given us some input, given some information to the algorithm, and now you want machine to predict a new scenario, right? So what you want, that whatever information you have given, it should predict based on that to a new information. But sometimes what happens, it learns so much to the information you have given in the new scenario, it just gets confused. All right, it just get confused. Okay, the information which I have taken, like according to the machine I'm talking about, the information which he was training, getting trained, that machine, he has learned that thing so much that he cannot perform well in new scenario. So in that case, guess what happens? You don't want him to learn everything from the information you are giving. You want some lag, some gaps in between that, so that he can also like go to the like new scenario and perform well. So it's just a layman terms. In layman terms, I'm talking about when we will go to that those bias variants and those lectures, then we will go in more deep, and then you will see this vector norms and L2, L1, L2 norm. These two are like used in Ries regression, lasso regression. So in that case, this everything will be more clear, like why we are studying this linear algebra.